Welcome to your first recording in algebra. So we are officially jumping into content this week. We are working in the week 2 folder, and each week I am going to create a recording like this for you where I'm going to go over important announcements if there are any, and then just go over what you're going to be learning this week in algebra. So I do ask that you have a math notebook and that you are also taking notes as you watch this recording. Taking notes is going to help you with the learning. When you take notes, you're more involved, and there's all sorts of research that shows that taking notes really does increase the learning process. So instead of just sitting back and watching the recording, I want you to be involved. I want you to grab your math notebook, take notes, and then remember you will be turning in your notes at the end of the week by taking a picture and uploading them. So make sure that you have your notebook out at this time. If you don't, go ahead and click pause and grab a notebook and come back. Yes, the ability to click pause is an awesome thing that these recordings offer. You can click pause, you can click rewind if you miss something. So take advantage of that feature and use it as needed. So every week I do like to start up with some warm-up questions. So in your math notebook, I want you to try these 3 warm-up questions. So let's get ourselves thinking back to the math we learned last week, I meant to say last school year, where we are going to solve for the variable x in each of these equations. So go ahead and click pause now and try these on your own, and then when you're done, you're going to check your work with mine. But I do want you to click pause so that you're actively partaking and participating, and you will get so much more out of these recordings. So go ahead and click pause and try these, and then when you're ready to check your work with mine, click play. All right, so the first problem is 2 times x equals -8. So we need to figure out what the number, when we multiply it by 2, gives us -8. So if we remember, to solve for variables, we always want to do the opposite of what's being done to the variable. So in this case, 2 is being multiplied by x, so the opposite of multiplying is dividing. So to solve this problem, we're just going to divide each side by 2. And -8 divided by a positive 2 is going to give us the answer of x equals -4, because a negative divided by a positive is a negative. X equals 4 for the first problem. Moving on to the second problem, I'm going to go to a different color here. So we've got 2x plus 2 equals 10. So this is a 2-step problem. The first step that we're going to do is get rid of this plus 2. So it's being added, so we are going to do the opposite, and we're going to subtract it on both sides. And when we subtract 2 from both sides, we're left with 2x on the left. 10 minus 2 is 8. So we've subtracted 2 from each side, and then we're at a 1-step problem, 2 times x, so we need to do the opposite of multiplying to solve for x, so we're going to divide each side by 2. And we get our final answer, x equals 8 divided by 2 is 4. So that's for problem number 2. And for problem number 3, I'm going to switch colors again one more time. Let's do it in green and go over here on the far right-hand side. We've got x minus 7 equals 8. So this is number 3, third problem over here. So x, we're subtracting 7 from x. So the opposite of subtracting is adding. So to solve for this problem, we're going to add 7 to both sides, and we would get x equals 15. If we would plug in 15 for x, we would have 15 minus 7 equals 8, and we know we did it correctly. So those are the answers to the 3 warm-up problems. And now that we reviewed a little bit about solving variables, we're going to jump into some content. But first, I should have done that on this page, nice and clean. let's see what we're going to do this week. So this week we're going to look at formulas and functions in Unit 1, Session 1. We're going to look at literal equations. And then in Unit 1, Session 2, we're going to look at absolute functions. So we're only doing 2 sessions this week. A friendly reminder of what you should be doing this week, since we're starting a brand new school year. Some of you are new to online learning. Let's remind ourselves what we should be doing each week. So each week, you need to be going through all the lessons in your weekly assignments folder. So this is where you're going to do the learning. So what I really want to remind you of is that you're going through the slides one by one, and you're clicking on the assignments as you come to them. If you go straight to the assignments, you're not going to know how to do the math. So it's really important that you're going through the lessons first, and then as you come to the assignments, complete them. Also, you need to be taking notes as you go through the lessons. I do require that you submit your notes, so make sure you're getting in the habit of taking good notes as you go through the lessons. And try practice problems also. In the lessons, there's lots of opportunities for practice. Take advantage of that and try that in your math notebook. And then one more reminder, and that's about redos. Remember, you can redo assignments only from the current unit. So sometimes our units usually take a couple of weeks. So you can redo assignments from previous weeks as long as they're in the current unit that we're working on. You can redo any assignment you wish, no matter the grade. However, I do recommend that you redo assignments that you get less than a 70% on. But if you got an 80% and you want to redo that to improve on that, that's fine too. I just want to make sure that you're learning from your mistakes. So take advantage of that opportunity to redo assignments. All right, so let's jump in to the first thing we're learning this year in your algebra class, and that is literal equations. So what is a literal equation? So a literal equation is simply just an equation that has a lot of letters, or remember when we see letters in equations, we call those variables. So a literal equation is just an equation full of variables. Here's an example of a literal equation. A equals L times W. And you might recognize it that is actually the formula for finding the area of a rectangle. Area equals length times width, but we use variables instead and say A equals L times W. Another example of a literal equation. This is actually A equals pi r squared. This is just an example, and it's the area of a circle it represents. But you can see there's no numbers involved except for the square. But all variables are being used. So both these are examples of literal equations. They're equations with variables. So in math, sometimes you're going to be given a literal equation and asked to solve for a certain variable. And then the goal is just to isolate or get that certain variable you're trying to solve for alone on one side of the equation. You're trying to isolate it. You're trying to solve for that. So that's what we're going to be starting out with session 1, is solving for literal equations. And the process is going to be the same process that you use to solve linear equations, or the same process that you use to solve those warm-up questions. You're going to go through the same process. The only difference is that you're going to be working with letters instead of numbers. So let's look at an example. All right, so here's a literal equation. A equals B times H. And I want us to solve for B in that equation. So we want to solve for B in this literal equation. So this is what solving literal equations are all about, is solving for a variable in an equation full of variables. So here's the original equation. A equals B times H, and we want to solve for B. We want to get B all alone. So how would we isolate B? Well, remember, B is being multiplied by H. So to get B all alone, we want to divide each side by H. We want to do the opposite of what's being done to B. So we're going to divide each side by H. So now our answer is going to be A divided by H equals B. And that's it. we can't simplify any further because there's no numbers. So this is our final answer. Looks kind of strange, I know, but that's it. If you want to write it as b equals, you get b on the left, that's fine. A divided by h, but that is our final answer. So let's look at this second equation here where we've got, we want to solve for w in the equation, in our literal equation, p equals 2 times L plus 2w. We want to solve for w. So I'm going to rewrite our equation. P equals 2L plus 2w. So our first step is we want to work on getting the w isolated. So let's move this term over here, the 2L. So in order to move it, I'm just going to subtract it from both sides. And that's an L, by the way. It's not a 21. It is an L. I should have maybe made it a cursive L to make that more clear. So on the left now, we've got P minus 2L equals 2 times W. And we're one step from being done. Remember, we're trying to solve for W. Get W all alone. W is being multiplied by 2. So we're going to do the opposite, and we're going to divide each side by 2 to get W all alone. And we're going to divide the whole entire left side of the equation by 2. And then we're left with our answer. Our 2's cancel out on the right, and we're left with our final answer, which I'm going to write up here. P minus 2L divided by 2 equals W. And that's our final answer. That's our final answer. One more problem. We're going to go through an example. So here we've got a literal equation, v equals 3k divided by 2. I'm going to rewrite that. V equals 3k, and we're dividing all of it by t. 3k divided by t. And we're solving for t. So right now, t is in our denominator. We don't want it in our denominator. In order to solve for a variable, we need to get it in our numerator. So in order to do that, what I'm going to do is I'm going to multiply t on both sides of my equation. Remember, whatever we do to one side, we have to do to the other. And then the t is going to cancel out on the right side, and we're going to have t times v, or vt. It doesn't matter where you put the v, if it's in the front or the back, it doesn't matter. Divided by 3k. And now we've got t in the numerator, and we can solve for it. So we've got v times t, divide that out to undo that multiplication. We're going to divide it. And we're left with our final answer. Our v's are going to cancel out on the right, left, and we've got t equals 3k divided by v. Oops, running out of space there. Let me rewrite that over here. 3k divided by t. Oops. 3k divided by v, divided by v. Let me fix that. Getting a little tongue-tied with all these letters. That's our final answer. T equals 3k divided by v. We divided each side by v to solve for t. So just a reminder, if you're solving for a variable that's on the denominator, we need to first move it to the numerator before we can solve for it. So that is just a preview of what you're going to see this week. You will have lots of lessons and videos, an opportunity to practice solving for literal equations. But I wanted to give you a preview of what you're going to see in session 1. Ready for session 2? So session 2 is all about absolute value equations. And I think a lot of you might have already have had some work with absolute values. So what is an absolute value? So an absolute value is a number's distance from 0 on a number line. So what do I mean by that? Let's put up a number line. So if we're dealing with, let's say, the absolute value of -4, what that means is the distance away from 0 on the number line. So -1, -2, -3, -4, -5. So since we're dealing with -4, what is the distance to 0 on the number line? Well, it's 1, 2, 3, 4 units away. So the absolute value of -4 would be 4, because that's what the absolute value represents, is the distance from 0 on a number line. Let's look at how we solve equations that have absolute values. So the steps are, step 1 is we want to isolate the absolute value equation. So meet the absolute value expression. So here it's already isolated. In this example, we've got x minus 5. The absolute value expression is isolated. That's all there is. And then step 2 is we're actually going to have two equations that we're solving for when we have absolute value equations. So to solve for them, we're always going to set up two equations. So the two equations that we're going to have is that we're going to set the quantity inside the absolute value notation equal to the positive and negative quantity on the other side of the equation. So that means we're going to take this absolute value expression, x minus 5 equals 3, and we're going to write two equations that we're going to solve for. So the first is just going to be x minus 5 equals 3, so that's the positive version of 3, and then it can also be equal to x minus 5 equals negative 3. And then we're going to solve for both equations. All right, so to solve for the equation on the left, x minus 5 equals 3, we're going to solve for x by adding 5 to both sides. And we would get x equals 8. So that's one solution. What's the other solution? Well, we're going to add 5 to both sides, but this time we're adding 5 to negative 3. Negative 3 plus 5 is 2. And that's our other solution. Whoops. So we're always going to have two equations and two solutions when we're working with solving for absolute value functions. If we plug in both answers, 8 minus 5, that equals 3. If we plug in 2, 2 minus 5 is, so if I plug in 2 minus 5, I would get negative 3, but remember that's the absolute value of negative 3, which is 3 units away from 0 on the number line. So the absolute value of negative 3 is 3. So either solution works. Both of them work. So again, when we solve for absolute value equations, we have to set up two equations where we set whatever the absolute value equation is, absolute value expression is equal to, we're going to do a plus and a negative version of that 3, just like we did here. A positive 3, and we set it equal to a negative 3. I'm going to go on to the next slide, so if you need more time here, go ahead and click pause. Let's try one more example. So the first step says isolate the absolute value expression. Well, we didn't have to do this on the previous example because our absolute value function was already isolated. In this case, it's not. We've got a 2 on the outside being multiplied by 2 times the absolute value of 4x minus 7. So the first step is we need to get rid of this 2 on the outside. So it's 2 being multiplied times 4x minus 7. Absolute value of 4x minus 7 equals 26. So first step is we need to isolate. We need to get the absolute value expression all alone. So to do that, it's being multiplied by 2. So guess what we're going to do? We're going to divide by 2 because that's the opposite. And then we'll have the absolute value expression isolated. So now we have just the absolute value of 4x minus 7 equals, what's 26 divided by 2? It's 13. And now we can go on with step 2, which is where we set up two equations. But you always want to have the absolute value expression part all by itself before you set up your two equations. So now let's set up our two equations. The first one is we're going to set it equal to positive 13. So 4x minus 7 equals positive 13. And then the other one is going to be 4x minus 7 equals negative 13. So remember, we always do the positive and negative version of what the absolute value expression is equal to. And then we solve for x. So I'm going to start by adding 7 to both sides, and I get 4x equals 20. Divide each side by 4, and one of my solutions is going to be x equals 5. 20 divided by 4 is 5. Then the other solution, we're going to do the same thing and start by adding 7 to both sides. But now we're going to get negative 13 plus 7. And we get negative 6. And then we're going to divide each side by 4 to solve for x. And my final answer is going to be x equals negative 6 divided by 4, which I know I can reduce. I can divide out a 2 of both my numerator and my denominator to get negative 3/2. And that's my second solution. So again, let's review the steps to solve absolute value equations. So our first step is we want to isolate the absolute value expression, which in this example we actually had to do. We had this 2 being multiplied by our absolute value expression. This piece is our absolute value expression. It's what the absolute value bars are around. So we needed to get that alone first. So we divided out the 2. Then you need to set the quantity inside the absolute value notation equal to both the positive and negative quantity that it's set equal to. So we did the plus and negative of what it was equal to. And then we solved for both of our equations. And we got 2 answers. So again, you're always going to have 2 solutions when you solve for absolute value equations. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. I'm going to have you try to solve this one on your own. So go ahead and click pause. Try this one on your own, and look at what we have here. We've got 2x minus 3, the absolute value, I forgot to say, the absolute value of 2x minus 3, and then subtract 4 from that equals 3. So go through the steps, try this on your own, and when you're ready to check your work with mine, click play. So click pause so you can try this on your own. All right, so first we need to get our absolute value expression all alone. And right now it's not. It's being subtracted by 4. So before we can set up 2 equations, we need to isolate that. So we're going to do that by adding 4 to both sides. And then we've got the absolute value of 2x minus 3 equals 7. Now we can set up our 2 equations where we're going to have 2x minus 3 equals 7, and we're also going to have 2x minus 3 equals negative 7. And then we're going to solve for x in each of them. We're going to add 3 to both sides. I get 2x equals 10, divide each side by 2. X equals 5 is one of our answers. The other answer, we're going to start by adding 3 to both sides. We get 2x equals negative 4. Divide each side by 2. We get x equals negative 2 because we're dividing a negative divided by a positive. So those are our 2 solutions. X equals 5 and x equals negative 2. So check your work, see if you can catch your mistake if you made any, and let me know if you have any questions. And I'm going to go on the next slide where we're going to wrap this up. So that's a wrap. So remember, each week for watching the recorded sessions and completing the key phrase assignments, you get 10 points. But in order to get your 10 points, you have to complete the key phrase assignment. So in order to get your 10 points, you need to answer this question, this specific question. You need to tell me what is a literal equation. So we went over in this recording what a literal equation is. And in your own words, I want you to tell me what a literal equation is. So to complete the key phrase assignment, on the next slide where you're watching this recording in Schoology, you're going to find the key phrase assignment on the next slide. So in case maybe you've logged out of Schoology, to get back there, just click log on to Schoology, go to your algebra class, click on materials, find the weekly assignments folder, find week 2, go into week 2, and then click through the slides, and the key phrase assignment will always be in the slide right after the recording. Type in your answer and click submit, and that's it. So have a fantastic rest of your week, and if you need help with anything, let me know. I'm here to help.